Hello everyone, my name is Sudheer Kumar, working as an assistant professor of mathematics, MLR Institute of Technology. In this lecture, I am going to cover topics Jacobian, properties of Jacobian, and the problems of Jacobian. Let us see the definition of Jacobian. Here, u and v are two functions of the variables x and y. Then the determinant of dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y. This determinant is called Jacobian of two functions u and v with respect to the variables x and y, and it is denoted by this dou of u comma v by dou of x comma y, or j, that is Jacobian of u comma v with respect to x comma y. This is the Jacobian of two functions. Suppose if there are three functions, say u, v, w, u, v, w. These are the three functions in variables x, y, z. Then the Jacobian of u, v, w with respect to x, y, z is given by this. This is the notation of three variables Jacobian. Dou u, v, w by dou x comma y comma z. That is determinant of ux, uy, uz. Means u suffix x can also be written as dou u by dou x. U suffix y can also be written as dou u by dou y and dou u by dou z. Next, second row. This is completely for with respect to v. Vx means dou v by dou x. Vy, that means dou v by dou y. Next, dou v by dou z. Last, w suffix x, that means dou w by dou x, dou w by dou y and dou w by dou z. This is the how we define the Jacobian of three functions u, v, w. Now there are few properties of Jacobian. Suppose if j is equal to Jacobian of u and v with respect to x and y, and j dash is the Jacobian of x and y with respect to u comma v, then this property holds good. J into j dash is always equal to 1. And second one, if u comma v are functions of Rs, and again Rs in functions of two variables x and y, then we define this Jacobian dou u comma v with respect to x comma y, but actually u and v are functions of R and S, so I can write dou u comma v with respect to dou R comma S, and again R comma S are functions of x comma y, so we write the Jacobian as dou R comma S into dou x comma y, right? So functions of functions, if we define, then we define the Jacobian of two functions like this. Next, let us see one problem on it. X is equal to u into 1 plus v and y is equal to v into 1 plus u. Then show that Jacobian of x comma y with respect to u comma v as 1 plus u plus v. First let us write what is given. Given that x is equal to u plus uv, I am multiplying each and every term. Y is equal to v plus uv. Then what is dou x by dou u? I am differentiating x partially with respect to u, that is 1 plus uv derivative is v. Next, dou x by dou v, I am differentiating x with respect to v, so here u is 0 plus v derivative is u into v derivative is 1. Coming to y, differentiate y partially with respect to u, so dou y by dou u is, this is 0 plus with respect to u means v, and dou y by dou v, y differentiate with respect to v, so v derivative is 1 plus u. Now let us write the Jacobian of x comma y with respect to u comma v, and the definition is dou x by dou u, dou x by dou v, dou y by dou u, and dou y by dou v. That is, what is dou x by dou u? 1 plus v, that is u, this is v, this is 1 plus u. So if you differentiate this, so we'll be getting 1 plus v into 1 plus u minus uv. That is 1 plus u plus v plus uv minus uv. This is equal to 1 plus u plus v. This is what he's asking to show, right? Next, x is equal u is equal to x square minus 2y, and v is equal to x plus y plus z. W is equal to x minus 2y plus 3z. Then he's asking to find the Jacobian of u, v, w with respect to x, y, z. So Jacobian of u, v, w with respect to x, y, z is defined as ux, uy, uz, vx, vy, vz, wx, wy, wz. First, let us find all these partial derivatives and substitute in that and find the determinant. So what is dou u by dou x? So let us write dou u by dou x is 2x, dou u by dou y is minus 2, and dou u by dou z 0. Next, dou v by dou x is 1, dou v by dou y is 1, dou v by dou z is 1. Next, dou w by dou x 1, dou w by dou y minus 2, dou w by dou z is 3. So let us find the determinant of this. 2x into this minus this into this. So 3 plus 2, 5. 2 into 3 minus 1, 2 plus 0. This is 10x plus 4. This is fine. We find the determinant. Let us do one more problem on it. X plus y plus z equal to u, y plus z equal to uv, and z equal to uvw. This is somewhat tricky question. We substitute to get xyz values in terms of uvw, because we want dou xyz in with respect to uvw. So we want all the three equations should be in terms of uvw. So first, given z is equal to, this is first equation, this is second equation, this is third equation. So from equation 3, z equal to uvw, z value is given. So substitute 3 value in equation 2. So we get y plus z, z means uvw, that equal to uv. That implies y is equal to uv minus uvw. So I got y value in terms of uvw, right? Now substituting y value and z value in equation 1. So I get x plus y plus z is equal to u. That implies x plus y means uv minus uvw plus z means uvw, that equal to u. Therefore x is equal to u minus uv. So I got x value, y value, z value in terms of uvw. Now let us write this value. Jacobian of x, y, z with respect to uvw, that equal to dou x by dou u, dou x by dou v, and dou x by dou w. Next, dou y by dou u, dou y by dou v, dou y by dou w, dou z by dou u, dou z by dou v, dou z by dou w. So that is equal to, what is dou x by dou u? You differentiate x with respect to u. So dou x by dou u is 1 minus v. Next, dou x by dou v, differentiate x with respect to v, that is minus u. Next, dou x by dou w, differentiate x with respect to w, there is no w here, so this value is 0. Next, dou y by dou u, differentiate y with respect to u, so what will be getting? Dou y by dou u is v minus uw, with respect to u, v minus vw, right? Uvw derivative with respect to u, so vw, so v minus vw. Next, dou y by dou v, y you differentiate with respect to v, dou y by dou v, that is u minus uw, u minus uw. Next, dou y by dou w, dou y by dou w, that is 0 minus uv. Next, dou z by dou u, dou z by dou u is vw, uw, uv. Now let us expand this determinant, so we will be getting the answer for the given question. This can be written as 1 minus v into u minus uw into uv minus of minus plus uv into uw plus u into v minus vw into uv plus uv into vw plus 0. So we'll be getting 1 minus v into u into uv, that is u square v minus wu into uv, that is u square vw, right, plus u square vw, so these two are cancelled, plus u into, multiply each and every term, v into uv, that is uv square minus vw into uv, uv square minus uv square w, uv square w plus uv square w, these two get cancelled, plus 0. So this is equal to 1 minus v into u square v plus u square v square, u square v minus u square v square plus u square v square. So this is u square v. This is the answer. Next problem. Given that u is equal to x square minus y square. So u is in terms of x and y. V is also in terms of x and y. Again, x and y are in terms of r and theta. So we want the Jacobian of u comma v with respect to r comma theta, dou r comma theta. So how will you define this Jacobian? Dou u by dou r, dou u by dou theta, dou v by dou r, dou v by dou theta. Right? First of all, I have to get u value in terms of r, but in the given question, u value is given in terms of x and y. First, let us write down that u is equal to x square minus y square. But what is x? R cos theta. X square means r square cos square theta minus y means r sin theta. I want y square means r square sin square theta. So this is equal to r square into cos square theta minus sin square theta. Cos square theta minus sin square theta is cos 2 theta. I can write this. So I got u value in terms of r and theta. Similarly, v is 2xy. So v is equal to 2xy. So 2 into x means what? R cos theta. Y means r sin theta. So this is r into r square. 2 sin theta cos theta is sin 2 theta. So v value is r square sin 2 theta. U value is r square cos 2 theta. Now I can differentiate u comma v with respect to r and theta and then substitute the derivatives here. So what is dou u by dou r? I want with respect to r. So cos 2 theta is constant. R square derivative 2r into cos 2 theta. Dou u by dou theta. Dou u by dou theta. Differentiate with respect to theta. So r square is constant. Cos 2 theta derivative minus 2 sin 2 theta. So minus 2 r square sin 2 theta. Next, dou v by dou r. Differentiate v with respect to r. So theta terms constant and r square derivative 2r and sin 2 theta. Next, coming to dou v by dou theta. So with respect to theta, I am differentiating. So sin 2 theta derivative is 2 cos 2 theta. So determinant of this is 2r into 2r square, that is 4r cube cos square 2 theta. So this is 4r cube into cos square 2 theta. Minus into minus plus 2r square into 2r, that is 4r cube. Sin 2 theta into sin 2 theta, that is sin square 2 theta. So if I take 4r cube common, I get cos square 2 theta plus sin square 2 theta. But we know that this value is 1. So 4r cube into 1, that is 4r cube. Therefore, Jacobian of uv with respect to r comma theta, that is 4r cube. That is what he is asking to show. So hence proved. So till now we have discussed the problems on Jacobian. Thank you.